Assalamu alaikum students. My name is Hassan. Today we are going to learn about chapter number 2 of class first year, which is about vectors. If we think about the two basic quantities of physics regarding measurements, these quantities are called scalars and vectors. Basically, scalars are the quantities which can be completely shown and described by their magnitude only. Let's suppose if we are thinking about the length, so we just have to tell about the length, which is, let's suppose, 10 centimeter. There is nothing else which is to be defined when we are talking about the 12 centimeter. So when someone says about it, this is 1 meter or 2 meter, then definitely he is saying about the length, which is about 1 centimeter, 1 meter, 10 centimeter, yeah, 10 meter. If we are thinking about the vectors, basically vectors are the quantities which are completely described by their magnitude and direction. It is necessary for us to describe the direction of a vector when we are saying about our weight, let's suppose. If we are thinking about the weight, then it is definite that weight is also acting downward, yeah, toward the center of the earth. But these vectors are completely described by their direction and can be added by a special rule which is called head to tail rule. An important topic of first year book of especially KPK board, which is about addition of vectors by rectangular components, is going to be discussed today. Basically, vector addition can be carried out by head to tail rule. So the basic rule for the addition of vector, by definition, the head to tail rule. Sometimes sketching a scale diagram for complex situation become difficult. So another method is described to add two or more than two vectors, which is called analytical method. This method is more mathematical in nature rather than the geometrical. By head to tail rule, our resultant will always approximately correct. So here we go toward our topic. Firstly, we are going to draw a diagram which is called Cartesian coordinates or rectangular coordinates. In this method, initially the rectangular components of given vector are calculated. The x component of the resultant can be determined by simply adding the x component of all the given vectors, which will be shown in this figure. So Cartesian coordinates are basically described by two coordinates which are called x-axis and y-axis, and this point is called the origin. At this point, the value of x and the y are both values is equal to 0. Let we suppose that a vector R which is acting, a vector A is acting in this direction, having tail at point A, and another vector B is added by using head to tail rule, having tail at point B. Is it okay? So according to head to tail rule, we are going to draw a resultant for this situation, and resultant vector is called R, which is equal to A plus B, as it said in the definition of the head to tail rule. So according to the rule of projections, I named the tail point of vector A is A and the vector B is B. I am going to change these names because these are resemblance with the vector name. So I am going to take it as x A1, A2. This point is going to be considered as theta 1, and this is the projection point of vector 2, which is theta 2. So the x component of the resultant can be determined by the simply adding the x component of vector A, which is called ax, and vector B, which is called bx, of all the given vectors, as we are going to discuss with two vectors. So Rx will be equal to ax plus bx. Similarly, adding the y components of all the given vectors, y component of the resultant can be determined. Okay. If we are going to find the Ry, as we know that the y component of the resultant vector, we have to add the both y components of the discussed vectors which are added in this case. But when we are going to find the magnitude of the resultant vector, so we are going to use Pythagorean theorem. The magnitude of the resultant vector can be computed. To find the magnitude of the vector R, the rectangular components method, we resolve A into AX and AY. This is called AY. This is going to be BY, the Y component of vector B, and the whole situation is called RY because the addition of AY and BY is considered as the Y component of the resultant vector. So according to the definition of the magnitude, as we know that magnitude is equal to R is equal to under root Rx square plus Ry square. So if the values of Rx and Ry are previously calculated, so we can put these values in this equation. So R can also be found with this formula, which is called ax plus bx whole square plus ay plus by whole square. But when we added more than if we added more than two vectors which are a and b, then this formula will be changed into a next formation which is called R is equal to, this will be something lengthy, ax plus bx plus cx plus nx. Nx means the last value of the vector which is added in this situation, which is called addition of vectors, plus y component of all the vectors, ay plus by plus cy plus ny of this whole situation. So this is called the formula for the magnitude of this situation, and the last one is theta, which is about tan inverse Ry divided by Rx. I think this will be easy for you. You have to put the Ry so that the y component value of the resultant vector, which is called Ry, is equal to ay plus by and cy and so on. So, and the next value of the horizontal component of the resultant vector can be substituted by this equation, which is called Rx is equal to bx plus cx plus nx and so on. So the steps for this method can be revised in this scenario, that we have to draw the individual vector being summed and x is being used. Find the x and y component of Rx and Ry, which are called the rectangular components of the resultant vector R. Find the magnitude of the resultant vector by using this formula, and at last find the direction of the resultant vector, which is called theta, and theta can be determined by the quadrant rule, which are called first quadrant, second quadrant, and third quadrant. So I'm going to represent you the basic scenario for method regarding quadrant method. So there are 4 quadrants in Cartesian coordinates which can be explained by, these are the 4 quadrants: first quadrant, second, third, and fourth. These quadrants can also represent the position of angle. At this point angle will be 0, at this point angle will be pi by 2 or 90, at this point angle will be 180 or pi, at this 270 or 3 pi by 4, and at this point the angle will be 2 pi or 360 degree. So if the resultant vector lies in the first quadrant of this scenario, the angle will be theta is equal to phi. The angle will be same in first quadrant. But in case of second quadrant, the angle will be, at this quadrant, the angle will be theta is equal to 180 degree minus phi. If the angle lies in third quadrant, then theta will be phi plus 180 degree, and in the fourth quadrant theta will be equal to 360 degree minus phi. So we can find the value of theta, the value of theta by using these methods, these formulas, and this will be easy for us. So this is the explanative lecture about the topic which is called addition of vector by rectangular components. I hope so this will be very helpful for you, because this is a very important topic of chapter number 2. This topic leads to the basic formulas to solve numericals in the exercise and the coming scenarios in chapter number 2 and chapter number 5 or 6. So this is the basic key to find the next solution of the upcoming chapters. I think so this will be very helpful for you. So thank you so much. Take care of yourself. Assalamu alaikum.